Right, in our last section, we want to talk about things that are really easy, actually, when I think about it. It's one of my favorite topics, radical equations. Okay, so when we're solving radical equations, these are obviously equations that have radicals in them. The procedure is similar to absolute values. That is, think of it like this. You got to isolate your radical first. Okay, just like you solved for the absolute values, isolate the radical. So it should be a radical equal to something. It could be another radical, it could be a number, and we'll get to that later. Okay. After that you've isolated, you want to get rid of those radicals. If it's a square root, you're going to square both sides. If it's a cube root, you're going to cube both sides. And if it's the nth root, what you're going to do is you're going to raise it to the nth power. Okay? Solving a resulting equation, you're going to get maybe linear, quadratic, so you might have to factor, it depends on the site. But you need to check it. Sometimes you're going to get extraneous roots. Okay? Roots that don't work. Check them, they don't work. Okay? If you have multiple radicals and numbers, you're going to isolate them one at a time, square both sides. You might have to do some extra work, but then you're going to get another radical, and maybe you have to isolate again and repeat the process. At the end, don't. So, let's take a look at some problems and see how we can solve them. So the first one I have is a basic one, just to get us in the groove. The radical is isolated, so once it's isolated, you want to get rid of the square root, so you square both sides. Squaring a square root gets rid of the squared symbol, so you get x minus 2 equals 25. Add 2 to both sides. Get 27 equals x, and we're done. Pretty simple, actually. Check. Just do 27 minus 2, square root of 27 minus 2, square root of 25, and that's 5. Now, people ask me, well, can it be plus or minus 5? Well, whenever we're dealing with these problems, you're always going to assume the principal root. This is because if there was a negative, there'd be a negative in front of the radical itself. Okay, these are always just going to ask for its principal root. Okay, let's take a look at number 2. Let's solve this one. First thing is we need to get that alone, so this has got to go. So how do we get rid of plus 7? You subtract it. So the square root of 2y minus 1, you subtract 7 from both sides, is negative 3. Now that the radical is alone, you square both sides. Well, that's just 2y minus 1 equals negative 3 squared, which is 9. Solve for y by adding 1. 2y equals 10. Divide by 2. Y equals 5. We check, and you see 2 times 5 minus 1 plus 7. Well, that's 10 minus 1, which is the square root of 9, which is 3 plus 7. That's 10. But it should have equaled 4. Does it equal 4? No, it doesn't. So guess what? That doesn't work. There is no solution. That's an example of an extraneous root we get. So let's move along to the third problem on my list. Okay? But I've got more stuff here, so I want to get my radical alone. So I got to subtract 1. Unfortunately, if I subtract 1 from both sides, these aren't like terms. So I just get x minus 1 equals the square root of x plus 5. This is where it gets a little bit confusing. Alright, so keep going. We're going to have to get rid of the radical. So we're going to square both sides. However, if we square both sides, it's easier to see it in parentheses. We got to square like this. That's where we're going to have to distribute this out. It's going to be x minus 1 times x minus 1. That equals x plus 5. Okay, square root gets rid of that. Well, FOIL it or distribute it any way you want. X times x is x squared. Minus 1x minus 1x is minus 2x. Plus 1 equals x plus 5. Subtract x and subtract 5 from both sides. X squared minus 3x minus 4 equals 0. Got it equal to 0 because it was a quadratic. Remember, we want to get quadratics equal to 0. Factor that now. X, 4, 1, minus plus. Okay, set each of those equal to 0. And solve. You get x equals 4 and x equals minus 1. Right? You got to check. Does 4 equal 1 plus the square root of 9? 4 plus 5. Now that's 3 plus 1, that's 4. So you're okay. Negative 1 equals 1 plus the square root of 4. Oh, wait a minute. That's 2 plus 1. That's 3 equals negative 1. This is where people ask, well, wait a minute, couldn't you make the square root of 4 negative? No, because we assumed the sign that was up there That's going to create the root we have. So 1 doesn't work in our equation. Our final solution is x equals 4. Our third or fourth one here, if we take a look, all we got to do is isolate one of them. Okay, there's two. We don't want to square them right away. We want to isolate one of them. So I'm going to move this one over to the other side, and we have 3 squared of x minus 2 equals 2 squared of x plus 8. This is where we're going to square both sides, okay? We could divide by the 2 or the 3, but it's easier just to square both sides. Remember, we're going to square 3, which is 9, and square this square root of x squared, which is just x minus 2. Now, you don't have to distribute this out because there's no plus in between there. It's one big multiplication. You can do the same over here. It's 4 times x plus 8. Distribute now. 9x minus 18 equals 4x plus 36. Nope, not 36, 32. We can do some good multiplication. Sounds like that. Somebody's got a case to Mondays. Subtract 4x. Add 18 to both sides. You get 5x equals 50. 80. Divide by 5. X equals 10. It's 10, I swear. Okay, check it. 3 times the square root of 8 minus 2 times the square root of 18. These don't look the same. But if we reduce this, this is 2 radical 2. This is 3 radical 2. 2 times 3 is 6 radical 2 minus 2 times 3, which is 6 radical 2. They're the same. Subtracting to get 0, and that's what we wanted to. So it does check out. We're good there. 2 to go. Just make this a big B. Don't think of it as a dot there. Right? Well, it's a cube root. Still the same procedure. Isolate. So subtract 2 from both sides. The cube root of b minus 2 equals 4. How do I get rid of a cube root? You're going to cube them both. Cube it. So if you cube both of them, you get b minus 2 equals 64. Because that's 4 times 4 times 4. Add 2. 66 equals b. Okay, if you check it, 66 minus 2, 64. The cube root of that is just 4, and 2 plus 4 is 6, and that's what it equals. Okay. Last one takes the most amount of work, which is, well, we got double the square roots, but we also got coefficients in there. Right? So you're still going to square both sides. Notice how it's isolated. I've isolated one of them. Could have isolated the other one if I wanted to, but I'm going to isolate the big one first. I'm going to have to square both sides. What's nice is it takes care of that first one, but the other one we got to actually do 1 plus the square root of 2x and 1 plus the square root of 2x. All right? You have to multiply that out. That's 1 plus 2 radical 2x plus 2x equals 3x plus 1. Well, that got rid of this radical, but we still got one here, so we need to isolate this one. So I'm going to subtract 1 and subtract 2x to get it alone again. Subtract 2x and subtract 1. 2 radical 2x equals, x. Now I'm kind of isolated. I could divide by 2, but I'm just going to square at this point. And if you square this again, this will be 4 times 2x equals x squared. You get 8x equals x squared. We have a quadratic, get it all on one side equal to 0. So I'm going to move the 8x over. And I'm there. At that point, I'm going to factor out an x. I have x minus 8 equals 0. X equals 0. X equals 8. Check both of them. Plug 0 in. 0 times 2 is 0. Square root of 0 is 0. That's 1. 0. 0 plus 1 is 1. Square root of 1 is 1. 1 equals 1. Try 8. 8 times 2 is 16. 16 square root is 4. 4 plus 1 is 5. 8 times 3 is 24. Plus 1 is 25. The square root of 25 is 5. Those are the same. So as you can see, isolate your variables, or isolate your radicals, square both sides, or cube root, or cube, or whatever you have to do, and then solve them. Watch out, if it's a linear, then it's a simple thing. If it's a quadratic, you have to factor. After that, make sure you check it. When you're checking, make sure you only plug in the positive roots. You don't have to worry about the negatives. And you have all the tools necessary to solve rational or radical equations.